class tomorrow because of the matinee. You can take your quiz after school today or Monday during office hours.
But you do this.
And those are your options. So figure it out. So here's a practice problem. As soon as you get your paper, go ahead and get
But
started.
I'm really just practicing my class. I don't like to. But I don't put working together. This quiz is just doing graph. It's like you look at one day.
Is it like this?
No. Yeah. Okay, well, listen to this. Okay, so you do X to the third. Say this is tissue, okay? And then you write all your.
All right, everybody get one? All right, let's see what we've got. What's the first thing you're going to want to do with this big mess? Factor. And hopefully you're going to observe that the numerator is going to factor by grouping. So let's work on that. I gotta fix my attendance real quick. Alright, so let's see. Did your numerator come down to be x plus 2, x plus 3, x minus 3? And then our denominator plus 3 minus 2? Is that okay with everybody? Alright, so we noticed right away we can do this. So now our problem is reduced to this. And before I forget, I'm going to have a whole where x is -3. So notice, not only is there a graph you're going to fill in, but you're going to fill in all these little things here too. So one of them is you got to fill in the holes. So if I put -3 back in here, what am I going to get? -1, -6, -5. So what is that? -6/5. So -3, -6/5. Alright, now what else do you notice? Now, this is our problem. What else do we notice about it? We have a vertical asymptote at x equals 2. That's my vertical asymptote. What about -2 and 3? Those look like they'd be special numbers. What are they? Those are zeros, or on the paper I called them x-intercepts, but those are zeros. -2 and 3. All right. How about a y-intercept? Y-intercept. If I put in 0, looks like I'm going to get 3. And then I need an end behavior asymptote. Notice I didn't say horizontal. End behavior asymptotes can be horizontal, right? End behavior asymptotes can be horizontal, if what? The powers match or the bottom one's bigger. But when the top one's bigger, it won't, I'll have an end behavior asymptote, but it won't be horizontal, it will be a slant, right? So I'm gonna take x squared minus x minus 6 and divide that by x minus 2. Did you get y equals x plus 1? Is that what you got? So I'm going to graph that. Y equals x plus 1. So here's my end behavior asymptote. So now I've got everything filled in. You're going to want to fill in those blanks. So we've got vertical asymptote, end behavior asymptote, poles, and our intercepts all figured out. Everybody's still with the program here. So really now, you either plot additional points of your choosing, or you kind of just logic it out. Can you see what this thing looks like? Do you have a visual for it? Okay, you got 3 points right here all in the line. So I don't think there's much confusion over here. That right there. And then over here, luckily, you have a point over here. So I don't think you're gonna be guessing over here either. There it is. Now let's answer the questions. The limit as x approaches -4. Now this one I threw in because I was looking at some calculus things and I thought, they need to be ready for this next year. Is there anything special in this picture at -4? Is -4 a special, like an asymptote or something? No, it isn't. -4 is just a random point on the picture. Where is -4? -4 comma what? It would be like over here somewhere. What would that be? -4 comma what? Let's see if I put -4 in. I get -2, -7, -6. So I got -7/3. Check my math, is that right? So as x approaches -4, from either side, isn't y just going to be -7/3? Yeah, a random point on the curve has limit behavior just like a hole does. You just plug in the x and whatever you get, that's the limit. Okay? So doesn't matter whether it's left, right, doesn't matter. The answer to that one, the limit as x approaches -4 from the right is, what did I say? -7/3. Okay? Now, let's go down. The limit as x approaches infinity. That's end behavior. What is happening the farther I go to the right? What is my thing doing? Positive infinity, right? Positive infinity. And right underneath that, what is happening as I go to the left? Negative infinity. Those are the end behaviors. Okay. 5. Okay, here's another one. Is there anything special about the number 5 in this problem? X equals 5. So again, would you agree that's just some random point on the picture? Put in 5, get a point out here somewhere. All right, what's the y coordinate? If I put in 5, 7 times 2, I got 14/3. Keep an eye on my arithmetic. So that would be the answer to that problem. It doesn't matter if it's a random point or a whole. It doesn't matter which side you're coming at it from, you're just gonna get that y coordinate. Now, is -3 something special? Well, kind of, it's a whole. So what's the limit as we approach -3? -6/5. And it doesn't matter whether we're approaching it from the right or the left, because it's a point. So it's coming together. Not like an asymptote where it's broken. They're coming together. How about x approaches 2? Well, now 2 is very special, because 2 is my vertical asymptote. So the first one says approaching 2 from the right. So what happens, here's 2, what happens as I approach 2 from the right? Which way is my pencil going? -infinity. And then what about from the left? Positive infinity. Any question about that? I'll try to be a little more organized on the real quiz, but that's what you're gonna do tomorrow, okay? You will also be doing that on your big quiz that we'll have next week, over 1.1 to 1.11. We'll have a big quiz next week, and you will be doing another one of these on that. But we decided we'd do one separately first and make sure we got it nailed down.
Will we have to do, long division on it?
No, it'll be just like this one.
What does UVA stand for?
In behavior asymptote. I gotta be careful, because I don't wanna say horizontal asymptote, because obviously this one doesn't have one. So we call them end behavior asymptotes.
But do you want to say like whether it's a span asymptote or a horizontal?
What now, what?
Like if you want us to just specify if it's horizontal or
You're right,
span.
the equation of the end behavior asymptote. So if it happens to be horizontal, you'll say y equals 2, or y equals 7, whatever it is. You'll know it's horizontal, because these, well, the 2 powers will match, right? Or the bottom one will be bigger. Okay, let's put that away. And,
Like on the vertical
let's look at
Let me just say, like,
the very last page of your notes packet.
it crossed out, but it was a hole, but it was also.
The very last page of
You
your
said
notes
no
packet.
before.
Let's look at these problems and make sure we got that stuff we were talking about yesterday.
So the vertical asymptote is the we just did there's no. Yes. So the vertical asymptote is.
Okay? So, first one says, write x minus 4 cubed in standard form. Now, when it's just being cubed, if you wanted to multiply x minus 4, x minus 4, x minus 4, that's fine.
So
I mean, that's what it is.
it's just the way I'm
Cubing isn't that big of a deal. But let's practice with Pascal's triangle. So if we are cubing, then we need to use the third row second row, right? Remember how this is built? And we have a 1 and a 1, and this would be 3 and 3. So there are our numbers. And that's the third row of the triangle. Now, since that's my binomial, then I'm gonna have an x and a negative 4 for each term. Each term is going to have a power of x and a power of negative 4. Because those are the two pieces of the thing. Now, I gotta put my powers on. Since this is to the third power, I know that my first term will have x to the third, agreed? And then what happens to those? They go down. And then what about the negative 4s? Same thing, other direction. Because each term, and these are individual terms, make sure you split them up. Each term has a degree of 3. 3, 3, 3, 3. And now we simplify. Anything to the 0 is just 1. So this first term is just x cubed. What about the next one? Negative 12x squared. Next one,
Plus 48x.
48x. And again, this is just 1. So that's going to be negative 64. And that's what you would get if you literally FOILed it out, which would be an option. That's the standard form. All right, let's look at number 2. What is the degree of this polynomial? This is some big polynomial. What is the degree of him? 6? X to the 6th? What is his leading coefficient? 2? So let's just pause for a minute, do a little review here. For this polynomial, what would be the end behavior? For this particular polynomial, this isn't a question, but we're reviewing. You have figured out that the degree is 6, and the leading coefficient is positive 2. So what does that tell you about this guy? So his end behavior is positive infinity on both sides. What is the constant term of the polynomial? So in other words, what's the y-intercept? What would the constant term be? What do you think? What? 30. Where does the constant term come from? Multiplying all of the constants? Because otherwise it's going to have an x on it, so you're just multiplying all the plain numbers.
Why would it be 30 if the plus 3 is to the 4th?
Oh, shoot! It's not. You're right. It's not. It would be 81 times 10, 810? Thank you. Good job, Leo. Wasn't paying attention. Good job. Leo says, wait, that's a third 3 to the 4th there. That's 81 times the negative 5 and the negative 2, so 810. Very good. All right, Kelly and Rowan are going to write this out. Kelly wrote this, Rowan wrote that. Is anybody right? I don't know. Let's take a second and figure it out. It's x plus 2 to the 4th. All right. So here we go. Which row of the triangle do I need? 4. So the fourth row. I got a plane X and a plane 2. And my powers for X start with 4. And, all right, so let's see who was right. Now they both started right. What's the next one gonna be? 8 x cubed? All right, so Kelly's wrong. Let's see if Rowan's right. What's the next one? 24x squared, 32x, and 16. I think Rowan got it right. Do you think so? And finally, in the expansion, x plus 2y to the 5th, which would use the 5th row of the triangle, there is a term, so you have all these terms just like this. One of them down the line has an x and a y to the 4th. Would you agree with that? Now remember that the two pieces of this thing are x and 2y. And our x is 1 and our 2y is 4. I need that coefficient out there. So it's going to come from the 5th row. If the power on the x is just 1, which term do I want? Not this one. 5, 4, 3, 2, 1. That one right there. So my coefficient is 5, because this is the term I want right here. That's x to the 1st. So what is that going to be when I multiply all this out? 80? Did you get 80? That's it. All right, let me check one more thing. That was the last page. Just go to the page right before that and look at problem number 2. Is x plus 2 a factor of this? How do you know? There are a couple of ways you could actually explain this. One that we have talked about and one that you did last year but we haven't talked about. What's your thought on that? Is x plus 2 a factor? What would you say?
Divide.
What?
Divide.
You could absolutely divide. Division will be a surefire way of telling, because if x plus 2 is a factor, then when I divide, my remainder will have to be 0, right? So I don't have any powers missing. 1, 8, 2, 2, 3. Uh-oh. Things are not looking good. So it's not a factor because it has a remainder of 31. Perfect. That will work every single time. There is another way though, if you remember some things you talked about last year. Do you remember the possible rational root rule? Knowing Miss Ludington, she talked about it in terms of P's and Q's. remember that if a rational number is going to be a root, in other words, if -2 is going to be a root, then it has to be generated by taking factors of 3, which are basically just plus or minus 3 plus minus 1, over factors of the leading coefficient. So the only numbers that could possibly, these are the possibilities, the only numbers that could possibly divide in evenly are 3, -3, 1, -1. If a number isn't in this list, it isn't dividing in. It isn't a factor. Now, does that mean that these are all actual factors? No, these are the possibilities, the possible rational groups. So you could use that explanation too, if you,
No, but I mean, but if you wanted to do this.
okay? All right, tomorrow,
But this is 0.
my aunt died unexpectedly, so I will not be here tomorrow.